Welcome back. In this video, we'll understand what role hash algorithms and cryptography play in blockchain. We'll also dive a little deeper in the SHA-256 hashing algorithm. Now, think of hashing like this. There's a person, could be me, you, or anyone, and we all have a fingerprint. And every person will have a different fingerprint. So, if you change the person, you'll get a different fingerprint. The probability of having two people with the same fingerprint is about 1 in 60 million. So, a fingerprint is an identifier of a person. Now, what if we could take this principle and apply it to digital data? So, we give this data some fingerprint that identifies this data for us. Well, such a fingerprint exists. It's called the SHA-256 algorithm. This algorithm was developed by the NSA, the National Security Agency of the United States. Now, the SHA and 256 stand for two separate things. So the SHA stands for Secure Hash Algorithm, and the 256 is the number of bits the hash value takes up in memory. And the hash is a hexadecimal value that contains 64 characters, both letters and numbers. So essentially it contains the numbers from 0 to 9 and letters from A to F, and each character takes up 4 bits of memory, because 4 to the power of 2 is 16 and 4 times 64 is 256. Okay, now this algorithm can be used to fingerprint any data, video, audio, text, or even the full operating system. Now we know what the SHA-256 algorithm is all about. So let's see what features make a hash algorithm like SHA-256 so useful. We'll go over the key requirements of a hash algorithm. First, it has to be one way, which means that you can put in some data and get a hash, but you can't access that data through the hash value, meaning you can't reverse engineer the data through the hash algorithm. Now the second, avalanche effect. So if I make a tiny change in the data, then the hash value will change radically. Similar to how in an avalanche, when you make a small change or take a small step in the snow, you cause a big blizzard, right? Okay, third, withstanding collisions. So if by a massive coincidence we have two pieces of data with the exact same hash value, which is possible because you have a maximum number of combinations for a 64 character hash value, and you can have unlimited amounts of data. So how do we deal with that? Think of the pigeonhole concept in maths. If you have 10 pigeons and only 9 pigeonholes, then you're going to have to fit 2 pigeons in the same pigeonhole. Now this is called a collision in blockchain, and there will be collisions, but that's okay because it's so rare. But our algorithm still needs to withstand artificial and malicious collisions. Okay, now fourth point is fast encryption. So basically this means that our algorithm needs to process the data and encrypt it as fast as it can. And last, fixed size. So you have some standard on which you can operate on. Now just to get a better understanding of hash values, I have this visualizer for you. So let's say I put in some text like hello world. Now you must have seen that every time I change the data, the hash value changes radically. So hopefully this gave you a better understanding of hash values, and in the next tutorials we'll start applying this knowledge. Thank you.